A liquid is exposed to infrared radiation with a wavelength of 4.50 times 10 to the negative 4 centimeters. Assume that all the radiation is absorbed and converted to heat. How many photons are required for the liquid to absorb 30.6 joules of heat? So the first thing you need to do to solve this problem is to convert the wavelength from centimeters to meters. So we are given 4.50 times 10 to the negative 4 centimeters. We know that 1 meter is equivalent to 100 centimeters. So the centimeters would cancel out, and this is equal to 4.50 times 10 to the negative 6 meters. Now that you have the wavelength in meters, you can now use the equation to solve for the energy of a photon. So if you can recall the equation, the energy of a photon is equal to hc divided by lambda. H is the Planck's constant. You should have memorized the value of the Planck's constant, which is equal to 6.626 times 10 to the negative 34 joule second. C, as we know, is the speed of light, which you should also memorize. That's 2.998 times 10 to the 8 meters per second. Divided by lambda is the wavelength in meters. So that's 4.50 times 10 to the negative 6 meters. So as you can see, the meters would cancel out, the seconds would cancel out, and the remaining unit is joules, which is the unit of energy. So if you solve this using your calculator, you will get the energy of a photon, which is equal to 4.414 times 10 to the negative 20 joules. So please take note that this is the energy of only one photon. Okay? And in the problem, we are required 30.6 joules of heat. So how many photons has the energy of 30.6 joules? So to solve that, we have 30.6 joules, and we know that one photon has the energy of 4.414 times 10 to the negative 20 joules. So as you can see, the joules, they cancel out, and our remaining unit is photon. And if you solve this in your calculator, 30.6 times 1 divided by 4.414 times 10 to the negative 20 joules, that's equal to approximately 6.93 times 10 to the 20 photons. And this is the answer to the question.